So this is a video to explain the differences between constant zones, spill zones and bypass zones. The reason I'm making this video is because we deal with people Australia-wide and in New Zealand many times with questions about how they work, why they work. Their installer doesn't want to do one, their installer does do one but only does this size. Thinks they'll blow systems up. There's just so many myths and misinformation around on something that to me is just so simple to understand that most of the general public seem to understand this at the time when they're purchasing one from us anyway. So this should give you a bit of information so that it helps you to know what you're getting before you're getting it, because at the end of the day it's your air conditioning system, it's your money, and if you want something done a certain way, it should be done a certain way. The first thing, constant zones. A constant zone just basically means it's a zone or an area of the home, an outlet, that has no control on it, no zone motor. So if you look at this system here, which is a whole home ducted air conditioning system, you can turn off every single zone in the house, but there's one outlet that doesn't have a zone on it here, and that has constant airflow, which is where it gets its name from, being a constant. No matter what you do with this system and turn things on and off, you'll always have air coming out of this outlet here into this area. The reason this was done at a time is because if you go back 30 plus years ago, there was no smart controllers around that would open and close these zone motors as they needed to based on what was happening inside the home. So to get rid of that, they just put in an air conditioning system. They zoned it with switches on the wall. You turn the rooms on and off, and if you turned all the rooms off in the house with the air conditioning unit still going, air would always come out of here, and you wouldn't have a problem with anything. The only reason that you ever need to have a constant zone, a spill zone or a bypass really is because when all your zones close, this air conditioning system will still be supplying air, and this air pressure build-up can build up on these joins and cause the duct to pop off, or it can build up on these motor blades and it forces these blades to break. It doesn't blow up your air conditioning system like some people will tell you. It's just a bit of a myth that happens. It just damages ducting. That's about it. But with a constant zone these days with zone stuff, it's a bit of a no-no really. You end up having an outlet here that the controller doesn't know it exists. It doesn't know the zone exists. You're wasting airflow doing this room that you could be doing another room with, so you're running the system on a higher fan speed than you probably need to. You end up putting a system in that's bigger than what it needs to be because you're wasting capacity doing this area. Having this one outlet on means it's not big enough to do this whole area because someone's gone and zoned to this one here. So really these two need to run at the same time. If someone doesn't want air conditioning here, they're going to get air conditioning. It's just a very crude and stupid old way of doing things that you just don't do it anymore. The other way people do it is like this. Again, it's the same thing, but it's just worse. So you've got a constant supply to these two this Y piece. You're dumping air into this whole space all the time. You're wasting 330 litres a second of air. Nearly 6 kilowatts worth of cooling capacity is just being wasted running all the time when you don't want it to. If you want to sleep in your bedrooms at night, you're running the system on a higher fan speed. The system itself's running faster just to try cool some bedrooms down because you're wasting it going into this area. If somebody is telling you that they're putting constant zones in, you need to look elsewhere, because it's an indicator to me, a red flag, that someone doesn't understand what they're doing or talking about. The only advantage is there's no mechanical component here to fail, but you know, they're everywhere else, and it's a bit of a dumb argument. The next option would be a spill zone. So a spill zone pretty much is that this home now is fully 100% zoned. Now inside the controller itself, whether it's a standard little 6-button thing, if it's an Airtouch 4, an Airtouch 2 Plus, an iZone, a MyAir, an Airtouch 5, any of that stuff, those control systems let you pick a zone that is a spill zone. So typically in a house like this would be your spill zone, because the spill zone needs to be a zone that has a large enough supply of air to safely relieve air pressure off of everything. a standard kind of little rule of thumb is for this system here, being a 14 kilowatt Aiken, does 900 to 1000 litres a second of air, probably does about 600-ish or something, 700 maybe on low. The spill zone, or constant or bypass, should be able to relieve or flow 50% of the fan on low. So this 350 will do about 385 litres a second. That can flow through this, so it'll do it fine. The problem with spill zones is that when you start using them with things like Airtouch 4s and Airtouch 5s or MyAirs or any of that stuff where they have temperature sensors, is they tend to run longer than what people want them to, and they create levels of discomfort for people. So the way this works with a spill zone is the spill zone typically opens based on a calculation of the percentage of your zones that are on and how far they're open. So if this zone was off at the moment and I just had this master bedroom zone on, when this master bedroom zone is 90% open, this spill zone will be 10% open. When this is 50% open, this will be 50% open because it's making 100. The control wants to see something 100% open all the time. If I turn on these two rooms here and they're both 50% open, this will be 0% open. If they're both 25% open, that will be open 50% because it's making up the remainder of the 100. When you start having temperature sensors in these zones with the Airtouch 4s and 5s, if I was to set this room to 24 degrees and I'm to set this room at 20 degrees because I want to have a nap on Sunday and someone's watching a movie in here at 24, once this zone gets to the temp it's set for of 20 degrees, it's going to have this zone fully open and this room will cool down to 20 degrees. Even if you've got it set for 24, once it goes into spill mode, it's going to cool this down to the set point of the coldest on zone. So if this one over here was 18 degrees, it would cool this down to 18 degrees, regardless of what you want it to be at. So I think the main reason it does that is because this outdoor unit for your Dakin system, it's not good for them to stop-start repeatedly. They should only sort of stop a certain time of an hour and a certain number of times an hour, I mean. And when they do stop, they have to have a break, and they have something inbuilt into them which is called a differential. So if you have this room get to 20 degrees and this was to go off, this wouldn't start again until this room gets up to 22, 23, maybe even 24 with some brands. By the time that does start to happen again, you start feeling uncomfortable in here. And ideally you want to get this room to 20 degrees and maintain 20 degrees. Maybe a degree is fine, but if you've got big variances, it's going to feel uncomfortable. And it's also increasing the amount this stops and starts. So to get past that, I think they just go and decide that this spill area here gets cooled to the coldest set point. As this heats up 1 degree, this opens again because the unit's already running and dumping cold air in here. It can dump some more cold air in here and it maintains that temperature perfectly. So for most of the time with a spill, if you're sleeping in all these other rooms at night and doing things, these temperatures in these rooms will stay perfect all day, all night. But this area here is going to end up getting too cold, colder than you want, not cold enough, and you're paying to cool all of this down. It's typically why you don't want to be using these. So the difference then is you go to what's called a bypass. This here is a bypass zone. So it works and opens in the same way this does with a spill. But the best thing it does is if I want to sleep in here at 20 and I want to have this at 24 because someone's watching a movie, that will get to 20, that will get to 24. This will start opening, it will bleed its cold air off through here, back through this return air path, and force this unit to stop. The process of this opening and making this stop happens much faster and much sooner than what it would if this started opening and started dumping cold air into here and this unit kept running flat out to try to cool this area down. All of that little spots where that would be happening are gone, and that's basically energy you're saving, and it's comfort that you're getting back, because if someone wants to be 24 in here, it'll be 24 in here. The other main thing it does, it seems like a lot of tradesmen aren't even aware of, is that as this is opening, because it opens incrementally, as this opens and cold air starts going back to this and mixing with this air from your return, it actually starts telling this unit to slow down much sooner. It doesn't just force it to stop. This Dakin system itself has its own logic in there, where it's just looking at how cold a coil is in here, what your set point is, and what your return air temp is. Because this cold air is coming back through here and making this coil cold, this outdoor unit starts to slow down because it realizes it doesn't need to work so hard. And the more this starts opening, the colder this coil is able to be kept, and the more that this starts slowing down even further, until such a point that this is fully open and a lot of cold air is going back to this. The cold air is well below the set point, so it goes off. And once that goes off, the fan is just sitting there blowing air around this little path here, and for some reason that air tends to stay like a cold little loop that just goes around. And then as these open, it just bleeds a little bit of air back into that room that's already cold. And even if this opens up to a point and closes to a point, once this outdoor starts, it starts on its minimum speed, which if you look at a Dakin unit for 14 is about 5 kilowatts out of 14 that it can run at. So the thing will just start to open, it will just start to speed up at about 5 kilowatts while it's bleeding some cold air in here. And because at 5 kilowatts of running speed, it's already keeping its coil cold enough while it bleeds a little tiny bit of air, it just won't really ramp up any higher than that. It's not until this fully closes and all these fully open again that it starts getting a lot of hotter air in here that it speeds up like it should. But you would want it to at that stage because you've got rooms, and a lot of rooms, that need a lot of cold air again. So the whole system responds to what's happening in the home a lot better. The outdoor unit itself speeds up and slows down a lot better, and it makes it far more energy efficient. Just, you can't beat it. The only thing it adds is one extra zone motor, 2 Y pieces, and a piece of flex, and you just have to make sure that it's in there of the correct size to handle, as we said with the spill zone. It just has to be of a sufficient size. But at the end of the day, it works far better than what a spill does. Spill works much better than what a constant does. So there's just times in some homes, like a standard house like this, it's easy to put this in there. There's plenty of space. When you do an apartment, or you've got a little townhouse with those little single pitch roofs or no roof space in it, or 2-story homes, sometimes adding this extra bit of ducting in, although it doesn't seem like much, is not very easy to get in there. There's lots of times you just can't put them in there because of the size of it. It's just way too tight. So it has to be installed at the right size or it just won't work properly. So hopefully this helps you out, and if you've got any questions, you can just get in touch with us and we'll be able to help you more, and we'll upload some other videos and some more information about units and ducting size.